Hey, what's up, people? This is a HandKey II by Recognition Systems. What the heck is a HandKey II? Well, let's see what the HandKey II installation and operations manual has to say about it. Here we go. The HandKey II is Recognition Systems' 4th generation biometric access control hand reader. The hand reader records and stores the three-dimensional shape of the human hand for comparison and identity verification. Upon verification, the hand reader produces an output that can unlock a door, send card format data to an access control panel, or communicate with a host computer. The hand reader also has auxiliary inputs and outputs that can be used to control other systems such as CCTV, cameras, and alarms. I couldn't have put it any better myself. So essentially, yeah, this is a hand reader for access control. We can see that it also has a keypad with numbers and a few other buttons, as well as an LCD. How does it work? Hey, we have an installation and operation manual. Let's go check that. And here we go. Principle of operation. The hand reader uses low-level infrared light, optics, and a CCD IC chip camera to capture a three-dimensional image of the hand. Using advanced microprocessor technology, the hand reader converts the image to an electronic template. It stores the template in a database with the user's ID number. To gain access, the user enters his or her ID number at the hand reader's keypad or uses an external card reader. The hand reader prompts the user to place his or her hand on the reader's platen. The hand reader compares the hand on the platen with the user's unique template. If the images match, the hand reader unlocks the door or sends the user's ID number to a third-party access control panel for processing. And that is exactly the sort of thing that I would have said. And now that we know what it is and have a general idea of how it's supposed to work, let's take a look at some of its physical features. And right away, we can see that the platen that they're talking about has this sort of a holographic sort of looking material where you place your hand. And there's also this sort of reflective looking stuff over on the right side. And this, as best as I can describe it, if you remember those like puffy stickers that were like pretty popular in the like the 80s and 90s, that's kind of what this feels like. So it's not like flat or anything. It does have like some like space feeling inside, and I don't know if maybe that's done on purpose to kind of create an uneven looking surface so that it maybe scatters light a certain way. I really don't know. If we turn it over and look at the left side of the unit, there is a mirror, and all of that appears to reflect up into this lens, which appears to be maybe like a sort of an infrared lens or something. I'm not sure. Let's clean this off. It's pretty dusty, and we can't really see anything in there. So the camera is going to be inside of the unit behind that lens. We have a lock on this side. There's nothing on the other side. There's the keypad. It's pretty grimy looking, so it does appear that this thing was pretty well used. You've got a couple of LED looking things right there. They're probably maybe like a red and a green one for like when it's accepted an entry or not. We can see we've got the branding of Recognition Systems, and apparently this is meant to be used by people that can hula hoop. And one thing we'll notice from the diagram printed on the front is that this appears to be only made for people with like attached to right hands. Although I guess you could totally Rayman it and have like wireless limbs and it'd still be able to use the thing. It doesn't appear that there's any way for somebody with like only a left hand to be able to use it. So it seems kind of Limbus to me. Sorry, left-handed only people, you don't get to use this cool machine. Wait, hold the phone, record scratch. If I'd have RTFM, I'd have seen that left-handed users are indeed addressed. I don't know why I didn't think about it, but they can just turn their left hand upside down and it'll work similarly to a right hand. It may be a little bit extra effort, but it's definitely an option. Taking a look at the back of the unit, we have access to all the connectors, and this is where we can apply power, and it's also got like all the outputs and inputs labeled on this chart. We've got some dip switches on this side. We got a barrel connector there. I guess this is so you can either put it like a little barrel plug there for power, or you can also power it through one of these blocks. And we can see right there that this is where you'd apply like 12 to 24 volts DC or AC. And so there we got some switched inputs, card reader inputs, and those are the outputs. Now, as we can see, it appears that this unit was using power on this block. And over on this other block, we're using pins 19, 20, and 21. If we take a look, we see 19, 20, and 21. So it says lock or D1 or clock. and then we've got ground in the middle, and then we have auxiliary out 0, D0, or data. So this device can activate locks independently, or, you know, like locks that are connected directly to this by way of like a relay or something. But I'm guessing that this was going to some other device that used maybe I2C data instead, because we can see it also supports data and clock. And I think that probably would have been the most secure way of controlling a lock, because otherwise you could just take like 2 of these wires and apply, you know, maybe like 12 or 24 volts or something, depending on whatever voltage the relay that was connected to it operated at. And so somebody could just rip this off the wall and easily defeat the security. But if it's done using data, then it's not quite as easy to defeat. On the side, we also have an RJ45 jack in there. So that's it says it's for a printer or host PC, and that's RS-232. So I'm guessing if we were to connect this to a PC through a serial port, we could probably see like data being printed out. And I did see on the manual that it says that there's no specific printer made for this thing, but that you can connect a serial printer to it. And as long as it accepts the right type of like protocol, it will print out a information like whenever somebody accesses this, or, you know, maybe like punches in like a pin on the keypad or something. So that pretty much does it for like an outside view of this device. Now, unfortunately, I would love to show you this thing in operation, but I can't, and that's not only due to the fact that I can't hula hoop. It also does not power up. I've tried powering it up, and it does absolutely nothing. And just to show that it doesn't do anything, I've got positive and negative hooked up to that set of wires that are going to the first block, and I've got the power supply there set for 24 volts. And if we turn this thing around, we can see that there's like absolutely nothing showing up, and it's drawing no current whatsoever. So I don't know if there's like a bad fuse or something inside this thing. We're going to take it apart anyway to see what's inside, and maybe in the process we can figure out what's actually wrong with it, and maybe we can play around with it a little bit. And the first thing we can do is remove these Phoenix connectors off the back of the unit, just so that we don't have these wires just flopping around all over the place. And then we've got 4 screws that appears that if we remove these, this back plate will completely come off. This ground is attached to that screw, but once we remove that, it should be completely free from the rest of the casing. And these just have like some coarse threaded screws for tapping into plastic. So there's all 4 of those out. Let's see if this will come off. And yes, it does. It's actually kind of hefty. It looks to be some pretty thick aluminum. And so we've got this hinge down there that it uses to mount. There's supposed to be like another plate that looks similar to this, but it has a kind of like a little tab that fits inside there and gets latched into that hook. And so this thing, if it needs to be serviced for any reason or whatever, it can be unlocked using that little barrel lock that we saw on the side and tilted down. And then you have access to these connectors on the back. So there's not as much in here as I thought there was going to be in the back. But that there looks like that's going to be the camera. That's the interface board that we can see from the outside, obviously. We got the LCD module. There's this little barrel-looking thing up here. It says S1. It's kind of weird. Oh, I'm wondering if this is a kind of like a tilt switch, so the unit knows if it's been opened or not. So, looks like the easiest thing to access is going to be this board. It's, I mean, there's really nothing else holding it in place. Can this connector unplug? Yes, it can. There we go. And then we can disconnect this connector. So this unit appears to be built to be easily serviced. Oh, there's a battery, and I did see that mentioned in the manual. There is an empty socket. I'm wondering if maybe something was removed from this, and maybe that's why it doesn't work. Well, that's going to be kind of disappointing if that's the case. I don't see like any fuses or anything right off the bat. There is a voltage regulator. Oh, I spoke too soon. There's a fuse right there that's been completely blown open. So this entire section of the board appears to be a switching power supply. So that's probably not a linear regulator. Cool. There may be some hope yet that we can actually see this thing in action. It appears that we can further dismantle this by removing some of these screws. It looks like this is separate from like this portion. So let's see what taking those off does. Okay, so the two on the upper portion that releases the display and the keypad. There is a connector for a battery. It appears there might be a mirror that's been sort of like silicone stuck in place. Okay, so there we go. And sure enough, there is a mirror. And that there is the camera. Looks like it's got a bunch of LEDs around it. Those are probably meant to be infrared. They have sort of a yellow tinge to them, so I don't know if they're just sort of like burnt up or if that's just the color of the lens on them. We'll find out in a bit. I'm wondering if we can actually see data coming off of this, if we can get this thing working. And there's that really dark piece of lens. It's like, can't really see anything through it. See what happens with the flashlight. Shield your eyes, people. Nope, that does not go through at all. And this platen board is actually coming apart now that I've removed the rest of those screws. And that mirror that we can see from the outside, it's glued on the inside. If we take a look at the surface of this material on the platen, it's not just like it's printed, it also appears to have like a certain texture. And as we can see, there's sort of like lines going in diagonal in this direction. And it has this pattern of these sort of like little diamonds with these sort of little eye-looking things on there. It's got a bunch of little tiny eyes looking at your hand. So I'm guessing this stuff is going to be some sort of like maybe a retro reflective material. There's nothing on the back, so it's just like stuck to the surface of this side. So there's nothing to look at on the back of that. It looks like it's just the white backing with some adhesive. So all the action's in the front. It's kind of nasty, man. People probably putting their hands on this thing after eating lunch, getting all of their Cheeto dust on the pegs. Let's take a look at the front keypad and display board. And there are a total of 6 screws that hold this board in place. There is a ribbon cable connecting the display to the keypad board. And while we're here and I take it apart, once I remove all the parts, I'll give this a cleaning, because if we can get it working, we'll make it so it's not so nasty. And this display does appear to be a 16 character by 2 lines. All right, that's all 6 screws out. Should be able to just lift this off, I believe. Let's see. Yeah, there it goes. So it looks like there's an additional 8 buttons on this side that are not used. Maybe there's another version of this device that would have additional functions. That's the silicone or the rubber button membrane. So that'll be much easier to clean without it in the unit. There we go. Nothing crazy down here. Looks like just like some carbon tracks for all the contacts. There are some LEDs in this little portion that has 4 LEDs, and those actually correspond to this little hand the diagram. So it looks like they light up maybe when you properly position your hand in the reader. Maybe they light up. There are no electronics on the actual platen that we saw, so basically these are all going to be detected by, if it works the way that I think it does, then these are all going to be detected by the camera itself. And I just had a piece of plastic fall out. So it looks like this was inside of the... Yeah, so I think it's just for support, because there are no LEDs on there, so it's not like it's going to light up or anything. The display itself is just held in with 4 screws on the corners, so I'll remove that. I mean, there's not going to be anything exciting about the display. So that's all, but the screws are moved, but one of them, it's got these inserts that are supposed to be mounted to this plastic lens, and this one came off, so it looks like maybe it was detached from the mounting post or something, so that can be easily glued back in place. But yes, this is basically just a backlit 16:2 line display. That there's the back of it. There's a model number PC1602 LRU, and it appears to be manufactured by some company named PowerTip. I would remove this plastic lens, but it's got these clips on these metal peg or these plastic pegs, and then they put epoxy on them, so I don't risk breaking them off. I'll just leave that alone. And here's a closer look at the board. This is pretty much where all the action is. There's that little, I'm guessing it's going to be some sort of a tamper device. It says S1, and as we can see, there's only 2 contacts. There's that outer looking one, and then there's something in the middle. It doesn't appear to be a tilt sensor like I originally thought. There is a buzzer, got 4 LEDs up there for those 2 indicators at the top that we saw. Those are the LEDs that I set for the finger placement. And we got a 4 megahertz crystal for what this is probably going to be a microcontroller. There's an additional 4-pin connector. It wasn't connected to anything. It was only using this side. So this microcontroller is most likely going to be communicating with the CPU on the bottom board using like some serial data most likely. Peel that stick. No surprises. It's a PIC micro. It's exactly what I thought it was going to be. Let's see. Is it a 16F873 or something? No, that's a PIC 16C63. So that's going to be like a one-time programmable part. And there's a closer look at that CAN switch. I'm guessing that maybe the way this works is if somebody tries to break into this thing and they knock this off, it basically detaches that pin from the rest of the CAN. Because I don't really, I wish there was like a number on it that we could look up and maybe we could figure out what exactly, it is. But there's absolutely nothing on it. And we can see that pin that comes out of the bottom, it's just kind of like barely tacked on to the edge. There's those 4 LEDs, and if we use a multimeter on diode to check, we can maybe see what colors they are. So that one's green. That one is, I can't make that one light up. Let's see what this one is. That's also green. And this is yellow. So I'm going to guess that this one is probably going to be red. It's a bit bright in here, so it's kind of hard to see these. But let's see. These are probably going to be green, I'm guessing. Oh, they have a different polarity. So there we go. So these are red. I thought that oh no, this one's yellow. And that one is also red. Oh no, that one is red. It just looks yellow on camera. But if you look at it in person, it's actually red. So yeah, so then this one's probably going to be red as well. Yep, it's red. So that's weird. On the green ones, the side with the little corner cutout is the cathode, and this is the anode. On the red one, that's the anode, and that's the cathode. And the battery connector on this board, it appears that it goes to a 12-volt battery pack. I did see some stuff about this in the manual. And so if you select the option on the bottom board, there's a tiny little jumper. If you enable that jumper, when the unit is powered up, it'll recharge the battery that you connect to that connector. And then it'll use that as battery backup in case the unit loses primary power. And it'll continue working until the battery reaches a voltage of it's at a 9 point something. I don't remember the exact value. So I actually went ahead and looked up a bunch of the part numbers for some of the stuff in here. Well, more of the specialized stuff. Some of the other stuff is just like general 7400 series logic. But the CPU, it's a Z8180 CPU. So this entire board is basically almost like a little computer in here. And this is a M27C 2001. That's a 2 megabit EEPROM, but it's a one-time programmable device. So this cannot be rewritten. And so that's going to be storing the firmware for this thing. It's got some RAM. And I'm assuming that this socket is probably for additional RAM. Maybe, I don't know if it'd be to store hands or patterns. It could also be maybe for operation. Not entirely sure. The RAM itself is an HY628100B, and that's a 1 megabit RAM, so 128 kilobytes. So a lot of this other circuitry in this section, it appears that it's probably going to be for address decoding and maybe latching of data so that, it's able to operate all the devices that are in this section, as well as probably interface some of the stuff for the input and output. And that's going to be running the real-time clock, which is actually on the opposite side of the board. So we'll look at that in a second. And the regulator IC, that is an LT1170. It's a switching regulator. So that's what's driving that other transformer on the bottom side of the board. This other little device is an HIN211CA. That is a RS-232 transceiver. So that's probably going to be working with this RJ45 jack in the back. And I did find the pinout for this. So if I can get this working, we could probably hook that up to the PC and see if, we can see what sort of data is being spat out. This other little device here next to the battery and the CPU, that's an ADM619A, and that's a supervisor IC. So that's monitoring different voltages on the board and, either resetting the CPU or maybe indicating other things. No idea how it's actually hooked up on the board, but that's what that can do. This is the real-time clock chip. That's a DS1202. So that's going to be the crystal for it. And so the battery's going to be like maintaining power to that. This little tiny device right there, that's a CSI 24MC04. That is a serial EEPROM. So I believe that this is probably where the information for hands that are programmed into the unit are stored, since it cannot write to this EEPROM, since it's a one-time programmable. My only other guess is that maybe the memory is battery backed, and so maybe when you program like a hand pattern to it, the CPU writes that information to the RAM. Otherwise, I would think that maybe the RAM is just being used for basic, like computer or computing functions, and also it could be so that when you put a hand into the platen, it'll store that information in the RAM, and then it can use whatever's like stored in the EEPROM to compare and see if they match. So that's my best guess as to how the the architecture in here might be working. And this other blocky looking device, that's a full bridge rectifier. That's so you can see right there, BR805D. You can see that the two pins in the middle are AC, and then it's got positive over there on the left and negative on the right. So that's over in this section where that blown fuse is. So I guess that's a good indication that maybe somebody did the wrong thing, or put the wrong voltage into the input, or something went catastrophically wrong and totally blew that fuse. So we'll do some tracing. We'll make sure that like nothing is shorted on, maybe like the power rails. Hopefully, nothing that runs on like 5 volts or whatever was damaged in the process. If like the CPU is dead, or, maybe like the flash is gone, then we won't really be able to do much about it. There's an additional pin header down the bottom of the board. No clue what that would be for. It wasn't connected to anything, as well as this other one. I'm guessing there was like some other options of, something else that could be plugged in underneath. There is another spot right there for a tamper device. So, but that is not populated. So it looks like it would be mounted on this side. And that's the transformer for the switching regulator section. Got some diodes. Oh, I just realized there's another fuse on this side as well. So that's pretty much it as far as like the specialized stuff goes. There's some other devices right there that I haven't looked up yet. That's a Max 913, and it turns out that is a precision TTL comparator. And that might have something to do with the camera module, because it's right next to the camera connector, which is this 10-pin connector right there to the right of it. Now, this one's kind of an interesting one. It's located just to the left of the Max 913. It's numbered 75451B. I found it as a Texas Instrument as a SN75 451B. And it appears that that's a dual peripheral driver for high current, high speed switching. And judging by its location, I'm guessing maybe it also has something to do with the camera. I took a look at the traces on the bottom, and it looks like some of them do sort of go off in this direction. So it probably does have something to do with the camera. And just to the south of the 75451, there is an SN75372. And according to the Texas Instrument website, that's a 10 milliamp / 40 milliamp dual channel gate driver with enable pin. I'm going to take a guess that this is probably doing some sort of interfacing with the connectors in the rear for like the input output. And if we keep traveling down, we see that we come across an SN75477, and there's actually 2 of those. So those are dual peripheral drivers, and it appears that they are high voltage devices capable of up to 100 volt outputs. So these are definitely going to be stuff that's connected to the connectors in the rear for like external stuff. And this is the last in line. That's a Max 487. That's a low power slew rate limited RS485/RS482 transceivers. And I don't know if there's any calibration done on this thing. It appears that these are just sort of like press fit onto those pegs, but I don't know if maybe, they did it with some sort of jig or something. They appear to be glued in place, so I don't think I'm going to be able to remove this board without breaking something. Okay, so with those 2 out, appears to be a fixed lens. It doesn't look like it's got any sort of adjustment externally. Kind of looks like the radioactive symbol. So there's just the 2 wires going to this LED board. I'm going to guess that they're probably all connected in series. I doubt that they'd be connected in parallel. And yeah, it looks like the actual material is just sort of like yellow colored. It's not that they're burnt up or anything. And there are a total of 10 pins on the header. I think we can figure out which ones are ground, which ones are providing power to the LEDs, and we can see if we can figure out which ones like the data pins are and all that stuff. Maybe we can do some probing, figure out what sort of data it's spitting out. The 2 traces for the wires going to the LEDs, those are pretty easy to figure out. We got one right there. We got the other one right there, or 1 and 2 that go off to the sensor. Those appear to be dedicated lines. This one goes to a via, but we can't see what's on the other side. I'm going to guess that that's probably going to be a dedicated line for maybe like that pin, because this one appears to be ground. So it looks like this pin is going to be ground. This pin comes up and around and to that pin, and that's connected to the positive of this capacitor. So that's going to be our voltage input. And so that leaves us with this pin, and that doesn't appear to go anywhere in particular. It could be maybe like that pin. That one's the only one that I don't see a trace for on this side. At least we can tell that we've got a total of about like 4 pins that are somehow doing data. I'm going to guess that it's probably like I2C. Could also be like SPI. Maybe one of the pins is like an enable. When then we would have it like clock data in and data out. And then we just have ground and power. So I think that makes sense. Let's see what kind of voltage these LEDs are working at. So we can bring up the multimeter on the top right corner, and we can check and see what kind of voltage each one of these has. So it's not that orientation, it's this orientation. So each one is about 1.14 volts, and we have 6 of them. So that amounts to just under 7 volts. Let's see, it's going to be about 6.84 volts. So we can apply some power to this and see it in action. The thing is that since they are most likely infrared LEDs, we're not going to be able to see it on camera. So what I've done is I've got this old analog security camera that I'm going to point down at the LEDs. And I can actually bring that up on one of my other capture devices. Here we go. So I'm just going to point that down at the LEDs. I'm going to connect some wires to the 2 pins that go to the LEDs, and then I'll bring up the power supply, and we should be able to see these light up. Okay, so I got some wires going to the back of that connector. I don't have the power plugged in just yet, and this camera looks blurry due to the fact that it doesn't have like autofocus or anything. It's manually adjusted, and it's not focused to be this close, and I'd have to take it apart to do that. So we're just going to leave it blurry for now. But I've got the power supply set to 5 volts, and I'm limiting it to 10 milliamps at the moment. Let's plug it in and see if it does anything. Nothing yet. We can't see anything. I'm going to slowly turn up the voltage. I wasn't paying attention. I was paying attention to the power supply. But yeah, we start getting to about 6.6, 6.7, and we can see that they are lighting up. 6.8, 6.9. So you can definitely see that they are infrared. We can't see it on this camera, but we can definitely see it on that camera. Oh, and also the reason we can see it on this camera is because it doesn't have an infrared filter. So there we go. All of those LEDs are working. So assuming we can get the rest of the device working, we should be able to try it out. Okay, so let's go back to the main board. Let's see if we can figure out if just replacing this fuse will do it, or if the problem's going to be a little bit more involved. Now, we know that the 2 pins on this end of the board are the power input pins. So let's see if there's any continuity between those to these fuses. Okay, so let's check continuity between each one of these pins and these fuses. Let's see what we get. Let's try this side first. Nothing there. And there we go. So that one goes directly into fuse 2. And the other side, let's see, will that go into fuse 1? Sure enough, it does. So we may be lucky here. Maybe this might be a little more simple than it could have been. So these are marked 100. So I think they are 1 amp fuses. So these are normally resettable fuses, but as we saw, this one's been completely blown open. So let's make sure that we don't have a short to ground between this end of the fuse, which actually has come detached from the board. So the pad there is no longer attached, but I'm just going to try to be careful. So if I touch that to this side, hopefully we should not have any continuity. I'm just going to have to go to that via. And that does not appear that there's any continuity. So that looks good so far. Let's see if these go directly into the bridge rectifier. So let's touch that there. Let's touch one here. Okay, that appears to have continuity. Let's check the other side. Hopefully it only has continuity on one side, because if it has continuity on both, then that means it's shorted. So that seems okay. Let's check this one to this point. And I'm checking it at that point because that trace runs directly to that little via. So that appears to be the trace that goes to the bridge rectifier. So let's see if which side was, the left side is positive. Well, I guess it doesn't really matter if we're just checking for continuity right now, but let's make sure that the output on this bridge rectifier is not shorted. And it does not appear to be, as the resistance is going up. It's probably just charging up a capacitor. Let's see if there is any continuity across like the positive side of one of these 7400 series logic chips. Hopefully we have nothing. Nope, it's it's going up in one direction. That's probably because we are also charging some capacitors. So that seems okay. Let's check voltage across this battery. And it has 3.05 volts, so it appears that it's okay. So what I think I'm going to do is, first of all, I'm going to remove that remaining chunk of the old fuse that's still on the board. And then I will put some sort of jumper. I'll see if I have a 1 amp, small 1 amp fuse that I can use in place of the original to put in that spot. And then we'll connect power to it. I will actually, since it can take any range from 12 to 24 volts, I'll probably do 12 volts. But I'm going to put it like a very low limit on my power supply. So that way, if something else is still wrong on the board, then at least, hopefully, like I don't fry anything or damage anything any further. And once we are confident that stuff is coming to life and maybe we'll see something on the display, then if it's still too low of a current, then, I'll raise it up or whatever. But we'll start there and see what it'll do. Let's remove this old piece of burnt fuse. I'm going to add some flux. And I'm going to bring in the hotness and just heat it up until hopefully it detaches. Hey, that was easy. So we can see that this trace is still attached, and it's a very, very thin trace. So I'm going to try to lay it down. I'm going to have to clean this off, but let's see. I would like to be able to glue this pad back on. Okay, I think I laid this on a little too thick. I'm having trouble getting it to cure. You can see that it's still pretty puffy underneath. And some of it actually went underneath this pad, which probably not a good thing because I'm not going to be able to cure it. But as long as I can get this area to be to harden, it should hopefully support the pad. All right, so I think I have a combination of issues here. One, I laid on the UV solder mask a little too thick. And also, I don't think my light is strong enough to penetrate it very well, so I had to scrape off some of the stuff that was there and pull it off, and then I was able to cure the remainder that was sort of underneath. So this is kind of secure. I'm not exactly happy with it, but there's not a whole lot I can do about it right now. So what I am going to do is just leave it as is for the moment. And I don't have one of these resettable fuses that I can replace in that spot. I'd have to probably order one. But I do have these 1 amp cartridge fuses that are for through-hole purposes. So I'm just going to put one here somewhere, maybe off to the side. And I can at least maybe glue it down. I'll bend the leads so that one will go to that pad and then the other one can stay on that pad. And that should hopefully be at least good enough to protect the board in case something happens. So I cleaned up this area a little bit with isopropyl alcohol, and I'm going to heat up the board a bit. And I'm going to take a tiny little piece of hot glue. I'm just going to set it down where the fuse is going to go. Try to get that to melt. I don't want to adhere that fuse really strong or anything. I just want it to be able to hold in place. Okay, I think it should be good enough. Bring it in. Okay, I think it's going to be just fine. And I'm going to take the leads and bend them, except I don't think these tweezers are strong enough. That should be good enough. All right, and just quickly hit these with the soldering iron and some solder. There we go. I don't want to push that any more than than I have to, so that should work. Okay, so we have our fuse in place. I think we are ready to test this, but actually I do need to put these back on. I removed the serial EEPROM that was there at U33, and I dumped it just in case, and I also removed the firmware EEPROM from the other side that was socketed, so that way, in case something does happen, at least we have a copy of, what was on it. And when I removed the serial EEPROM, it kind of freaked me out for a second there because I was actually heating it up with hot air to try to get it to the solder to melt, and so I could detach it. And it actually made this a little puff. It went like, and then some stuff came out the side. But I think maybe it was just something that was in that via sprayed out or just kind of boiled off or something. Because I was still able to dump it just fine, and it seems to be okay. So it doesn't appear that it came from the chip. All right, that's done. And we can pop the ROM back in its socket. And I think we are ready to try to fire this up. I mostly reassembled the keypad, a portion of the device, and so I have everything back on. I've got the connector going to the main board. I've got 2 alligator clips going to 2 points. One's grounded, and that's going to the multimeter. And I believe this test point is a 5-volt or part of the 5-volt rail because I did see some continuity between that point and some of the ICs. So the camera assembly is reattached, or optical sensor. And I have 12 volts on these leads. I have limited it to just the 400 milliamps. So we're going to see if this thing comes to life by applying power to these 2 wires. And let's go ahead and bring up the multimeter in the shot. So that's just going to check and see if this is 5 volts. If that is not 5 volts and it becomes something higher, then maybe I'll just shut it off real quick because I don't want to fry anything. So let's see what happens. Here we go. And making contact now. And it's drawing 146 milliamps. Oh, it's on. It appears to be booting. It's drawing about 160 milliamps. And it says ready. And it even has the correct date. It's got the wrong time, but I mean, who knows what time zone this thing was installed in. So apparently there was nothing wrong with it. Maybe just something catastrophic happened at the power input, and then I just realized I don't have 5 volts up here. Why not? I'm guessing maybe those are grounds then. That's weird. Well, we can see what the infrared LEDs are doing. I'm just going to bring this camera back into the shot. Let's go ahead and bring that up in the corner. And it does not appear that they are on. Oh, actually, maybe they don't do anything until you punch in a code. Let's see. I'm going to try to punch in just some random number. And nope, it rejected it. I don't have anything programmed in here, so I'm going to have to look at the manual and see how I program something into it. All right, so I'm looking through the manual. It says to enter a command menu, you push the clear and enter key simultaneously to enter a command menu. If no one is enrolled in the hand reader, then the display appears as follows. So it'll say enter password. However, if users are enrolled in the hand reader, then the display appears as follows. It says ready, and then I'm not sure if it's just supposed to show asterisk and then the colon there, but if we go to the device, if I push clear and enter at the same time, we get that. So I think that's where it's expecting me to put my hand in the reader. Oh, no, wait, it says enter ID number. So since I don't have an ID number or anything like that, I'm going to have to completely wipe this thing. And in order to completely erase everything, that's going to require modifying the dip switches in the rear. So it says to erase the hand reader setup, you have to have the system off, and then you set switch 4 to on. But this only erases the programs and it keeps the user database. We want to do both because, I mean, it's kind of useless to me without any knowing any of the previous info. So we're going to completely erase everything. And it says to have the system off, set the switches 4 and 5 to on. And then power it on, wait 5 seconds, and then turn both switches off. So let's go ahead and try that. Okay, so I'm going to just disconnect one of the power leads going to it, and I'm going to turn switch 4 and 5, which are the furthest right ones on this side. Turn those on. And so I'll power it up for about 5 seconds. 2, 1, and then I'll remove power. Turn them back off. And now everything should be wiped. And I think that what this is doing is it's storing all of that data in RAM, because there's really not a whole ton of stuff saved on that EEPROM, and it can't write to the other chip that has the firmware on it, because it's a one-time programmable chip. And I did do a test on the memory chip that's in there, and it does have 3 volts going to it, so it is being powered by the battery. So let's power it back up. So now when we hit these 2 buttons, we should be able to get into the menus. Let's see what happens. Enter password. Okay, there we go. So these are the passwords. It's 5 for security, 4 for enrollment, 3 for management, 2 for setup, and 1 for service. So when we go to the enrollment menu, we're going to have 2 options. We're going to have an option for add a user or add or remove user. All right, so I'm going to hit both buttons again. And for enrollment, that's number 4. Did it not take that? Ah, there we go. It just doesn't show it. So add user, we're going to hit pound for yes. And ID. Okay, I'm going to need you guys to like look away for a second. I'm going to make like a super secret code. So yeah, just go ahead and close your eyes. And you got your eyes closed? Okay, cool. All right, I'm going to enter in my code, but you're not going to know what it is. So it's going to be 1337. All right. Ah, man. Oh, well. Anyways, okay, we're going to hit enter. And place hand. So we got to do that 3 times apparently. And now we got these LEDs are lit up. Okay, this thing's like kind of awkward to get in the shop, but let's go ahead and try it. Here we go. Okay, so the LEDs turn off when you're properly positioned. So attempt number 2. Okay. And number 3. There we go. User enrolled. Okay, we're not going to add another user. We're not going to remove a user. I said no. Okay, maybe I have to hit clear. Okay, goes back to ready. Okay, let's see. So I'm going to punch in my super secret code, which was hit enter. Okay, there we go. It's asking me to place my hand. These LEDs up here, I didn't see them light up, so
access granted.
ID verified 13. I don't know what that means. Wait, did that light up? Did I just miss it? Let's try it again. Ah, yes. So this one lights up green. So I'll try it with my left hand now and see what it does. And I gotta try to do it somehow where I can get all these LEDs to turn off. And this is not working. I need one more. I can't get that finger to bend far enough to turn it off. There it goes. Try again. Okay, so it lights up red. Just a quick side note. The user ID isn't limited to only 4 digits. It can be longer. For example, we could have one that's up to 9 digits long, or a maximum of 10. And it doesn't matter if anyone else knows your user ID. Without your hand, they can't gain access. Although for that to happen, they'd probably have to go through some questionable methods. Yeah. Now, I'm really curious to see what the platen looks like when it's going to scan your hand. So I've got that little analog camera again, and we're going to bring it up in the corner. And let's see if we can see what that looks like. I'm trying to eliminate as much light as possible from in around it. So let's see. I'm going to punch in my code again. And so it strobes. And it's making the camera go all out of whack. So there we go. So yeah, it pulses the those infrared LEDs. So warning once again for anybody that may be sensitive to strobing lights. Yeah, and then if we look inside, yeah, it's just making it go completely crazy, but yeah. And looks like that continues for a while until you put your hand on there. Yep. Okay, I don't know how well this is going to work, but I took that camera apart so that I could have access to the lens so I could focus it, because the image sensor that's normally inside, the light bounces off that mirror that's up on top, and then it goes down through that. It's basically a visible light filter, so it allows infrared light through, but not visible light. So I'm going to try to position this so that we can see if we can get an image of what the sensor normally sees when you put your hand on the platen. So now I'm going to turn this light off. And because this has its own infrared LEDs, Let's see if it'll work. Okay, so we have an image of the platen. And when we put our hand in place, that's what it looks like to it. You can see the mirror is kind of hard to position here, but the mirror's on that side. So it looks like it's maybe, you can see where my finger's wiggling. Let me blow up this image. I think that's about as good as that's going to get. Well, so I'd put my hand in there, and you can see in the mirror that it looks like it would take two different, the lengths of your fingers. Maybe it detects that. That little reflective piece is over on this side, but I can't really see it with this camera because I can't really pop it in as far as the other one goes in. But yeah, so it's most likely going to be like a black and white sensor, and maybe the way that it does its 3D image thing is by, see how like my hand is not like uniformly lit, so maybe it'll detect some of the shades or the spots where the fingers are like darker, and that's how it forms the pattern for individuals' hands. Like I said, I really don't know how this actually works, so I'm just kind of guessing here. But that platen is extremely reflective to the infrared light. Okay, and the last thing I want to try to do that I can think of is I want to see what the data looks like coming from this sensor to the main board. So I made this custom cable that I can plug in between both boards, and then I have 5 wires that come off of that. They're just basically tapped from the ground, and then the 4 signal lanes that I identified earlier. So all 4 of those are going into this board. I'm going to hook up a USB cable from here to the PC, and then we'll be able to capture some data when the hand reader is trying to capture your hand image. We're not going to see what it actually looks like, but we can see what sort of data is like being spat out by the sensor. Okay, I think I've got everything ready to go. I'm only capturing 4 signals because that's really all we need. And I've got the image of the platen on this camera. So I'm going to hit run after I've typed in the code into the reader. And right before I hit enter, I'll hit run. And we'll see what it looks like and what happens when I put my hand into it. So punching in number and run enter. Uh-oh. It's not working. Okay, I've been doing some troubleshooting, and unfortunately, this is apparently not going to work. We did manage to capture some stuff, but there isn't really anything that I can tell here. And obviously, I can't put my hand on it because it never asks me to put my hand on it. It just says remove hand, so it's not detecting properly. And when I have any of the wires connected to this board, it just doesn't want to do anything. The only other thing I could try doing is maybe just checking each pin like one at a time with my scope. Maybe my initial thoughts of there being some analog signals coming out of this. Yeah, maybe that's possible. So everything behind this thing looks absolutely disastrous. I've got all 4 scope probes plugged into the 4 lines that are going to the sensor unit. And we're going to bring up the scope capture. And so we'll try this again. So we can see that line number 4 is that dark blue one. That's sitting at about 4.5 volts or so because I have everything set to 1 volt per division. So let's try plugging in the code again and hitting enter and see what it does. Oh, wow. This thing's going crazy. Okay, and I can see why this was not working. It's because those voltages are like way higher than 5 volts. So, whoops. Let's see. Let's bring this stuff down a bit. So that's at 5 volt per division. So that's pulsing away on. Okay, and it timed out. Yeah, let's bring everything to 5 volt per division. So it looks like maybe from like this point over to like this point is one maybe frame of data or something. We can see how it looks like that's where it restarts. It looks pretty much identical to that portion there. So yeah, and unfortunately, I think the only way to be able to make some sense of this stuff would be to remove the sensor from the assembly, but I think that's going to be kind of destructive because it's all glued in place. And I think part of the reason why it's stuck onto these sort of little plastic mounts That's probably for adjusting the focus. Yeah, I'd have to break those off and get to the sensor, but I think it'd be cooler to try to do something with this thing. I don't know what just yet, but I think it would be cool. Oh yeah, and there's still the serial port to probe. All right, I think we're ready to capture some RS-232 data. And I've already set up the HandKey to output RS-232 data to a host device. And I'm having to do this in an extremely convoluted way because unfortunately I don't have like a USB to RS-232 adapter that I can just readily use. I could put something together, but that's going to take me longer to do than what I did here. So I've got this old Armada laptop, and on the back, I've got the serial cable coming out, and then I had to kind of like make a makeshift adapter to go from like the connector on the end of the cable into the connector on the HandKey, and I actually just took basically some Cat 5 wire, and I just stuck it into the pins that are used. So it uses pin 4, 5, and 6 for ground and receive and transmit. So that's plugged into the RJ45 on the back of the HandKey, and then I got a VGA cord coming out of the laptop into a VGA to HDMI converter, and then that's going to my capture device. So it's, yeah, it's pretty crazy. But let's get this up on the screen. Okay, there we are. I was having some technical issues, but I think I got it resolved. So I am going to punch in my code into the HandKey, and then when it asks me to put my hand onto it, I will do that, and then we'll see what pops up on the hyper terminal. So let's go back to that. So I'm entering my code, and now it's saying place hand. Okay, place hand, verified, and nothing happened. Oh, there we go. So I totally misunderstood the setup. When it's in host mode, it's for like a PC controlling the thing. But when it's in printer mode, then it can spit out data. So as soon as I switched it over to printer mode, it spat that out. It says leave command mode. So now let's see what happens when I enter in my code, hit enter, and put the key. I mean my hand, the key. There it goes. Identity verified for ID 1337. Tamper activated. Ah, that's interesting. Door open too long. So some of this stuff probably has to do with the setup of the actual like physical device. I didn't like configure any of the outputs or anything, but I mean, we can see that this thing is working. And with all that, I think I've been playing with this thing a bit too long. I've been at this for several days now. So I think I'm just going to wrap it up here to get this video finished up. But I hope that was kind of interesting. It's cool that there wasn't anything like seriously wrong with the thing, and we were able to get it working so that we could actually see it in action. And yeah, that's going to do it for this one. Thank you all for watching, and I'll see you guys around the bench.